All right, so for problem number 7, it says Peter rides his unicycle, um, which has a wheel diameter of 0.47. And if the combined weight of Peter and the unicycle is 70 kilograms, what is the rolling force or rolling friction force due to the rubber wheel rolling on concrete? So first of all, I think when we go to do this, we need to figure out what the coefficient, and I see that I have a typo here. So let me correct the typo real quick. There we go. So to find the coefficient for rolling friction, I've got to do a little bit of math. And then from there, it should be pretty easy. So let's start there. So the coefficient, remember this is mu for rolling friction, is this B value divided by the radius of the tire. And so if the diameter is equal to 47 centimeters, then that is 0.4 meters, right? And so then 1/2 of that is what the radius would be. So the radius would be 1/2 of that, which would be 0.235, I think. 5 meters, right? But let's double check that for sure. So we'll go into Desmos. And we'll use the scientific calculator. And we're going to say 47 divided by 2. Yep. And actually, I should say 0.47 because we had to convert it to meters divided by 2. There we go, 0.235. All right, so far so good. No mistakes yet. So in other words, to find the coefficient of rolling friction, I'm going to need this 0.02 meters. And divide that by the 0.235. And so the coefficient, I probably should have started with this. Remember that in order to find the frictional force, to find friction, I probably should have started with this, and I apologize. But remember, to find the frictional force, and if we do it according to our notes, the frictional force due to rolling, which will be a lowercase f, due to rolling is equal to the coefficient of the force, right, times the normal force. I always say think of fun. And also remember that, and we'll write this over here, the normal force is the opposite. It's the mass times the acceleration due to gravity. So I needed this to plug in here. And now to find the normal force I have, because they've given me the total mass, right? So the mass is equal to 70 kilograms. Oh, wait, I still got to finish this. So my coefficient is this number. So I'm going to go back into my calculator, and I'm going to say 0.02 divided by 0.235, and I get 0.085. So we'll round that to 0.085. And it's a multiple choice question, so, we might be off a little bit because we're doing some rounding, but that's okay. So that's done, okay? That's what it is. So the next thing is to find the normal force. So to find the normal force is going to be 70 kilograms times 9.8 meters per second squared. And if we do that in the calculator, I'm going to take this number, 0.085. Oh, no, not yet. No, wait. Let me think. I got to do the normal force first. So the normal force was 70 kilograms times 9.8 meters per second squared. So that's about 686 newtons total. Okay. So this is about 686 newtons total. Okay. All right. So now to find this, I'm going to take this number, which is the coefficient for friction of rubber on concrete, and that's going to be 0.085 times my 686 newtons. And so the frictional force, rolling friction force, is going to be 866 times my 0.85. Whoops. Clear. It's going to be 686 times, and let me do it in order. It's going to be 0.085 times 686. So it's about 58.3. Textbook says 58.4. And that's just because of rounding. I rounded that one number. So it's 58.3, but they rounded it somewhere in their calculations. They probably used, instead of 9.8, they probably used 10 or something. I'm not quite sure. So the textbook says that it's about 58.4, and that's okay. That's one of the options on the multiple choice. Okay? So let me go over that again, because I feel bad in the way that I presented that question. I just started doing the calculations without explaining why I was doing the calculations. So in order to find the frictional force, I needed to do this stuff. Okay? I needed to do this. So to find my frictional force, I needed to know that the frictional force for rolling is equal to the coefficient for rolling times the normal force. So then what I needed to do is I needed to calculate the coefficient, right? And so to calculate the coefficient, we have B divided by the radius of the wheel. Okay. And when we did the math on that, we got that the coefficient of rolling between rubber and concrete is going to be this 0.085. And so we would plug that in the formula. The next thing that we needed to do was find the normal force. So the normal force is just the mass, and in this case, it's a combined mass of Peter and the mass of the unicycle, times the gravitation, the acceleration due to gravity. So when we crank through that math, we got the 686 number. The formula says just multiply those two numbers together. And when we were done, this was our actual answer, but the textbook and the multiple choice said that was the final answer there. Okay, that's it.